All right, this video is going to show you how to use the Anova spreadsheet that was uploaded on the course. Here's the example that we're talking about. We're comparing 4 different cities. The listing price of a random sample of 2-year-old Honda Civics was obtained for 4 cities in the United States. The data is summarized in this particular table, and we always have to assume that the distribution is approximately normal for all 4 cities. So I listed the prices for the Chicago. There are 2, 4, 6 of them. 5 for Los Angeles, 6 for New York, and 4 for Honolulu. Now, in the null hypothesis, we say that all the mean prices are equal. The alternative says not all mean prices are equal. We're using a 5% level of significance. Now, copying this information onto the spreadsheet, we copied all the prices for Chicago, for LA, for New York, and for Honolulu. So that's all you really have to do. We enter the group names and we put the data in. The Anova table, all of a sudden, if the alpha were different than 5%, let's say you wanted to make that 1%, if you would type that in, you'd see that the critical F changes, but that's about the only thing that changes. Here we're going to leave it as a 5% alpha, and you know the critical F changes. Notice that the p-value will stay the same regardless of what it is. The only thing that we have to do in order to draw a conclusion is compare the p-value to our alpha. So once again, we have our p-value, and we're just going to copy it, compared to the alpha. And remember, we want the alpha to have the same number of decimal digits as the p-value, so we can increase it just for ease of comparison. And for these particular situations, we notice that the p-value is definitely less than our particular alpha, because you basically have a 3% situation, or almost 4%, which is less than the 5%. Therefore, to draw a conclusion, we say that the results are significant. Therefore, we reject the null hypothesis. Now, at this point, we do not know exactly which one is significantly different than the other. We just know that we have all this information. Just to review with you, the degrees of freedom, because there are 4 classes, between the groups, we take the number of classes minus 1, which is 3. The total sample size would be a total of 21, and 21 minus 1 gives us 20. And the difference between the 20 and the 3 is the 17, is that's within the groups. So that gives you the degrees of freedom if you were going to use an F table, which gives you the critical F value. Notice that the calculated F is greater than the critical F, and therefore we also reject the null hypothesis that way. The p-value is the way that most people do it. When you are looking at a statistician, they will usually give you the p-value, and you will have to determine the level of significance. So basically, the only thing you have to do is recognize the fact that you are comparing the means for different groups, and you want to be able to determine if one is significantly different than the others. All right, now just play with this particular template, and that will help you determine whether or not you reject or not reject the null